Our lesson for today will be looking at BNU 1501, that is basic numeracy. The topic for today will be looking at measurements, and the subtopics is perimeter and area. We'll be focusing on questions from assignment number 3, which is question number 4 and question number 3 and 4. Let us start. There is a lesson video whereby we looked at question 1 and 2, and we've looked at the equations to calculate the perimeter for different types of shapes, but we can quickly go through them and review that part. So for a square, the perimeter is, we can say we have A. We know that the properties of a square, all the shapes, all the sides are equal, are the same. So we have 4 A's. So it's A plus A plus A plus A, it will give us 4A. And then we have a rectangle. We can say we have a height and a length. And for the parameter for this shape, we have this side plus this side plus this side plus this side. But we know the properties, opposite sides are the same. So we also have length here, we have height here. So it means the parameter will be h plus L, which will be 2h plus 2L. And then we have the triangle. The parameter will be, let's say we have A, B, C, will simply be A plus B plus C. And then for a circle, we said the circumference is equals to 2 pi r. We need the radius of that particular circle. This is very important for the equation, the question that we'll be looking at for today. Looking at the question for today, we have this diagram here. This diagram, we need it in order to answer question 4 and 3. So we have to analyze this diagram and be able to answer the questions. Now, analyzing the diagram, we can see that the overall shape is a rectangle. And we can say we do have the sides, we have this height, we have this length. So it is simple for us to calculate the parameter of this shape. But then the question says, it's question 3, determine the perimeter of a gray shaded part of the figure. This is the gray shaded part of the figure. So what we can do, let us look at the shapes which we have within this figure. So we have a triangle here. We have a triangle here. And then we have another triangle here. Not only 2 triangles, but we have a third one here. So what we can do in order to answer this, we only need this part. And you can see this part, it is not one of the shapes that we've looked at as examples. But we can analyze this. We can see that from here to here, we have 19 centimeters. But also looking at this part here, from here to here, we know that is 12 centimeters because it's 6 plus 6, it should give us 12. So we know that this part plus this part, it's equals to this part. So what we can do, we can simply use equation to calculate the length of this part. Remember that for the parameter of the part where the question is asking to calculate the parameter, we only need this plus this plus this plus this plus this, and then we are done with the question. But the problem is we are not given this part here, but through calculations we can calculate that part. We know that this part is 6.5, and we also have 6.5 here. And if we calculate this part, it will be the same as this part, then we'll be able to calculate the parameter. So we can start by saying 19 centimeters is equals to 6 plus 6, it will give us 12 centimeters, plus we can say this is side x. Transposing 12 to the other side, we have x, it's equals to 19 minus 12. That will give us 7 centimeters. So it simply means that this side we have 7 centimeters, and also this side we have 7 centimeters. Then we can calculate the parameter because we have all the sides. So to answer the question, we are going to say parameter is equals to 5 centimeters plus 7 plus 7 plus 6.5 plus 6.5, which will give us 32 centimeters. That is the parameter of the shaded part. So that is option 1. And then we go to question number 4. It says determine the combined area of the gray shaded part and the part shaded with black lines. For us to actually understand the question, let me zoom in the diagram. So we are looking for the area of this part combined with this part. Means that we are going to add the two areas. We need the area of this, then we add it with the area of this part here. Then we are going to get our answer. But before we do so, remember that I don't just answer the questions. We have to learn something from this, because there are questions which are waiting for you to answer them after the lesson. Let us look at the area of the basic shapes. Let us start with square. We know that the properties of a square is all the sides are the same. And then to calculate the area, we simply need two sides. We need this side multiplied by this side. So it means the equation to calculate the area of a square is a multiplied by a, which will give us a squared. And then for a rectangle, we know that we have the height and the length. The area of a rectangle will be calculated the same as the area of a square. So we have the area multiplied by L. It's actually the area is equals to L multiplied by H. And then lastly we have a triangle. Now the basic area equation of a triangle will be half multiplied by base multiplied by height. That will be the basic equation to calculate a rectangle. Now we know that we have different types of, a triangle. We have different types of triangles. We have an isosceles, and then we have scalene, whereby we know that all the sides are not the same, and then we have equilateral, whereby all the sides are the same. So looking at the shape without wasting time, we have to check what type of triangles we have. Looking at this triangle, we can clearly see that this is a isosceles triangle because these two sides are the same and then one side is different. So that is an isosceles triangle. Looking also at this one, it is also an isosceles because this side is equal to this side. So we have identical triangles here. And then looking at this one also, we can say it is another different isosceles from the two because these two sides are the same, but this side is not the same as those two sides. We have 5 centimeters there. So just to fill in the information here, we have 12 centimeters here, and then we have 5 centimeters here. So for these three triangles, we have information, complete information. We can say this is also 12 centimeters. But the procedure that I'll be using, or the method I'll be using to calculate the area of this part and this part, we are going to calculate the area of the whole shape and then calculate the area of the two, and then it will be the whole shape, the area of the whole shape minus the area of the two shapes. We'll get the remaining area. So that is how I'm going to calculate this. Another method you can use, you can calculate the area of the whole shape and calculate the area of the shapes, the three triangles, and then it will be the total area. You can say total surface area, which is the area of the whole shape, equals to the area of the shaded plus the area of the first isosceles. You can say isos, which is the first, plus the second isosceles, the second one, which is this one, plus the area of this one. Or you can simply, okay, we are going to use this one to calculate the area of this one, the area of the shaded line. So after calculating it, you will have this, and this, and then you minus the total surface area with the known areas to find the shaded. Then the shaded plus this one should give you the answer. But I think that is the long route. We can simply calculate like I said, we calculate the area of the whole part and then we minus the two and then we'll get the answer. But before we start with the calculation, just know the area of isosceles. There is a lesson whereby I actually derive this equation, but the area of isosceles, it's half multiplied by base multiplied by the square root of a squared minus b squared all over 4, provided we have a, and a b here. B in this equation is our base, and then a is the two sides which are the same. So let us go back to our diagram. So looking at this diagram, we can start with, this is the first isosceles, this is the second isosceles. But looking at the properties, we can see that they are actually the same. So if we calculate the area of this, it should be equals to the area of this. We don't have to calculate 2 times. So let us start with the overall. The overall shape, it will be this side, since it's a rectangle, multiplied by this side. So we are looking at the area of the overall shape. We have L multiplied by H. So the length here should be, it's actually 19 centimeters. So we have 19 multiplied by the height there is 5. Our area is 95 centimeter squared. So since we have the overall, so that we don't get confused, let me actually write the equation. The total surface area of the entire figure is equals to, let me just say this is the blue one. I'm going to use this color for blue, we use this color for pink, we use this color for red, and then this one for yellow. So the surface area is equals to the area of the shaded part or the blue part plus the area of the pink part plus the area of the red part plus the area of the yellow part. So the question, it says we need the area of the blue part combined with the yellow part. So now we've calculated the total part. We just need to calculate this, and then the remaining parts will be A and will be blue and yellow. That will be the answer. Combining blue and yellow, we should find our answer. So now we are done with the overall part. Let us calculate the area of one of the isosceles. Then we are going to multiply it by 2 since they are identical. So the area of one of the isosceles in our case the base is 12 centimeters, and then we have 6.5 centimeter, 6.5 centimeters. The equation, it's equals to half a base the square root of a squared minus b squared over 4. Let us go ahead and substitute. We have 1 over 2. Our base is 12, and then we can say multiplied by the square root. Our a, we have 6.5 squared minus our b, we have 12 squared all over 4. We get that the area of the isosceles is 15 centimeter squared. So this simply means that from this we have 95, it's actually 95 for the entire figure. We get 95 centimeter squared. For the blue one we don't have it, and for the pink one we have 15 centimeter squared. Also here we have 15 centimeter squared. So we have 15 plus the red one is also 15 plus the A1. The A1, I mean the yellow one. But in this case we are going to have two unknowns, because now we are looking for the shape of, the area of this, so that we can add it to this. So let us go ahead and calculate the area of this shape here. The isosceles, we have 6.5 centimeter, 6.5 centimeter, but we have 5 centimeters here. Let us use the equation again. it's half base square root of a squared minus b squared over 4. We go ahead and substitute. We have half, the base we have 5 in this case, square root of a, it is still 6.5 squared, minus our b, it's no longer 12 but it is 5 squared over 4. We find that we have 15 centimeters squared again. So going back to our diagram, we have 15 centimeters squared. So in order to get this one, we just have to take the total minus all the areas that we have. Here we said we also have 15. So we transpose, we have A, which is the A for this one, this A. We transpose everything to the other side, we have 95 minus 15 minus 15 minus 15. We get that the area of the shaded part is actually 50 centimeters squared. So 50 centimeters squared plus the yellow one, we are going to get 65 centimeter squared. So that is the actual answer. The area we get is 65 centimeter squared. Let us check the options. So you can see we have option number 4 as our answer. Answer is option 4, which is 65 centimeters squared. Well, there are questions which you have to do in order to consolidate your understanding in this chapter. Just let me know, then I will send you those questions. That's it for this lesson video. This is Wahula SJ. Thank you very much.